Homework 5, we made it to the last page. Congratulations. Problem 11 and 12. I gave the answers to this one on the previous video. So you're going to put current or voltage in there, and I think it's going to be 90 degrees for both of those. Just get the correct order on that. And another spoiler alert, I'm working out problem number 13 for you. This is a series connection of an inductor, resistor, and capacitor. Here are the values given in the problem. And I'm going to work this one out using the complex notation for the impedances of the resistor, inductor, and capacitor. So in complex notation, it's just the impedance of a resistor is just the resistance, so it's 50 ohms. The impedance of an inductor is the complex number J, that's the square root of -1, times omega L. Omega is given in the problem to be 500 radians per second. And then you want to make sure that this inductance is expressed in terms of henries, not millihenries, and I get 50 ohms for that. Double check my work on those, please. And then there's J. So this is an imaginary number. The same. You also get an imaginary number for the impedance of a capacitor, minus J, 1 over omega C. Double check my calculation on this. I get minus 20 ohms. To find the total impedance of a circuit, of this circuit, you take the impedance of this one plus this one plus this one. Because they are in series, that means you take this plus that. And you take, that means the real part here, and the two imaginary parts combine to give you this one. And then finally you take these answers here and go back over this way to find the polar expression. You take the square root of 50 squared plus 30 squared, square root, to get this value. Double check my work again. Inverse tangent of 30 divided by 50, I get 31 degrees. Repeat this process for different omegas, and you're going to find out that the impedance is different. So that's the difference between AC and DC circuits, is that the amount at which a circuit impedes the current depends upon the frequencies, and that of course is related to these omega values, the angular frequencies. On the last problem, the only difference here is that now you have only two components rather than three, and that these two components are in parallel rather than being in series. That means that the total impedance is going to be equal to 1 over the impedance of the first component plus 1 over the impedance of the second component. And so you'll get kind of a complex expression over there, and you'll probably want to use the complex conjugate to get it to look like a real plus an imaginary part to translate over here. Let me double check that. Never mind about that, because it looks like both of these are going to be imaginary impedances. So I think you're just going to get a pure imaginary number over here. That'll make it a lot easier.